You probably think you know shapes like squares and rectangles, right? But what if I told you they're all part of one big secret family? Today, we're going to pull back the curtain and map out the entire family tree of quadrilaterals. And trust me, you'll see some connections you never expected. So let's be honest, we all know these shapes, but how are they really related? Is a square just a special kind of rectangle? And what's a rhombus got to do with anything? It can get a little messy. So let's clear up the confusion once and for all and see how it all clicks together. Okay, every family has to start somewhere. And for our shapes, this is it, the quadrilateral. Think of this as the great-great-grandparent of them all. The rules are super simple. All you need are 4 sides, and the 4 angles on the inside have to add up to 360 degrees. That's it. Any shape that follows those 2 rules is in the family. Now, families really start to get their identity when you introduce some rules. So what if we take a random quadrilateral and we add just one new rule? That one pair of its opposite sides have to be parallel. Well, that gives us this guy, the trapezium. See, the family is already starting to branch out. A trapezium is a nice start, but things get really interesting when we get a little stricter. So what happens if we're not satisfied with just one pair of parallel sides, and we insist on a second pair? And bam, that brings us to the parallelogram. Now, you're gonna want to pay attention to this one. This shape is a huge deal. It's basically the parent of most of the famous shapes we know and love. By adding that second pair of parallel sides, it develops some very specific inherited traits that it's going to pass down to all its kids. And here are the most important traits. Just by becoming a parallelogram, 2 things automatically happen. First, its opposite sides aren't just parallel anymore. They're also the exact same length. And second, its opposite angles are always equal to each other. Think of this as its core genetic code. Every shape that comes from the parallelogram will have these traits. Now for the really cool part. Let's look at the secret DNA of these shapes. They're diagonals. You know, the lines that cut across from corner to corner. In any parallelogram, they always cross each other. But is it just random, or is there some secret rule that decides how they meet? Well, the secret is actually hidden inside the shape itself. If you look at the 2 triangles that the diagonals create, the ones on opposite ends, if we can figure out what's going on with them, we can crack the whole code. And the proof is actually pretty simple. Because of those family traits we just talked about, the parallel lines and the equal opposite sides, we can prove that these 2 triangles are completely identical. And here's the kicker. If the triangles are identical, it means the diagonals have to cut each other exactly in half. They bisect each other. This isn't just a coincidence. It's a fundamental rule for every single parallelogram out there. Okay, so we've got our parent shape, the parallelogram, with all its built-in traits. Now let's see what happens when it has children. To create a new generation, all we have to do is add one more specific rule to the mix. Let's try this rule first. We'll take our parallelogram, but now we're going to force every single one of its corners to be a perfect 90-degree right angle. What shape are we going to get? And there you have it, the rectangle. Think of the rectangle as the firstborn child of the parallelogram. It inherits all the base family genes, like having parallel sides and diagonals that cut each other in half, but it adds its own unique genetic marker, those 4 perfect 90-degree angles. And that new rule about the angles? It gives the rectangle a special diagonal superpower. On top of cutting each other in half, the diagonals of any rectangle are also always the exact same length. That's its unique piece of diagonal DNA. Okay, what about the other sibling? Let's go back to our parent, the parallelogram, but this time, let's forget about the angles. Instead, let's try a totally different rule. What if we make all 4 sides the exact same length? This gives us the rhombus, the rectangle's sibling. It's also a parallelogram, so it gets all the same core traits, but its unique feature isn't about angles, it's about its sides. All 4 of them have to be equal. And you guessed it, this rule gives the rhombus its own unique diagonal superpower. A rhombus's diagonals aren't always equal in length like a rectangle's. Instead, they have a different party trick. They always cross each other at a perfect 90-degree angle. They're perpendicular. So let's put these 2 siblings side by side. Both come from the same parent, the parallelogram. The rectangle gets the all angles are 90 degrees rule, which leads to its diagonals being equal in length. The rhombus gets the all sides are equal rule, which makes its diagonals cross at 90 degrees. See? 2 different paths from the very same parent. So we've got these two distinct siblings, each with their own special trait. But what happens when those two lines combine? What kind of super shape would be born if it inherited the best traits from both the rectangle and the rhombus? And that shape, of course, is the square. It's the ultimate descendant in this family because it follows both of the special rules. It gets the equal sides from its rhombus heritage, and it gets the 90-degree angles from its rectangle heritage. It is the perfect blend of its entire lineage. I mean, just look at a square's family history. It is a quadrilateral, so it has 4 sides. It's a parallelogram, so its diagonals cut each other in half. It's a rectangle, so its angles are all 90 degrees and its diagonals are equal. And it's a rhombus, so its sides are all equal and its diagonals are perpendicular. It literally gets every single family trait we've talked about today. So there it is, the whole family tree, laid out nice and neat. It all starts with the basic ancestor, the quadrilateral. Then you add 2 pairs of parallel sides and you get the parent, the parallelogram. From there, the family splits. Add 90-degree angles, you get a rectangle. Add equal sides, you get a rhombus. And when you combine both of those rules, you get the most specialized descendant of them all, the square. Which leaves us with one final thought. If a square really is a type of rectangle, and it's a type of rhombus, why do we even bother having 3 different names? Well, it's a good reminder that in math, just like in life, sometimes being more specific helps you describe the world in a much more powerful way.